We are reaching the final steps of your categorical data analysis. So far, we have constructed individual confidence interval for the two proportions, and we also have run analysis on the difference of the two proportions. The proportions that we compared again is a proportion of those who think job security interferes with family life for two groups. One group who says yes, that their job security is good, and those who think that their job security is not good. Now, this ultimate test of independence for our contingency table here will determine if job interfering with family life depends on whether job security is good or not good. Now, to run this test, you're going to have to assume that the two categories are independent. And under that assumption, you're going to have to find the expected counts or expected frequencies. Okay, so I go here and say, let's assume there is independence, or independence holds true. All right, and find the expected counts. And let's put this in boldface. All right, now remember that the expected counts for each cell, for instance, this cell right here is the product of the row sum for that cell and column sum divided by the grand total. In my case, the grand total is 3453. You can do this product for each cell, but that could take a long time, especially if you have a contingency table that is big, like the original contingency table. I'll show you a shortcut where you can implement the formula and apply it to all cells. Okay, so let's just say let me zoom in. Say I type in equal, I click on the row sum, and then I times by the column sum, and then I divide by n, which in this case is 3453, press equal. I just obtained the expected frequency for that cell, and you notice the expected frequency is not too close to the observed frequency. That is a contradiction to the assumption of independence. That's what we think at this point, but we don't know if the difference between the expected under independence and observed is really significant. That's why we need to find the p-value and complete the procedure. Okay, now let's say you want to apply this formula that I just implemented in that cell to the entire thing. If you drag the cell down, you're not going to get what you wanted. Here it says there is an error in value. If I double click on that cell, what it did is that it took E14. Well, E14 is this cell right here, the 2040. It times it by C16. C16 is the cell that contains yes. That's not a numerical number. We wanted that C16 to be C15, the 2943 instead. So when you're dragging down, these cells get dragged down too. So this traditional way of doing it is not going to work, but you can make some corrections to fix this. So let me hit enter. I'm going to delete these since this method does not work. This is what you can type in. Type in equal to, start with a $sign. $sign. Now my row sum, let me zoom in. My row sum is sitting in the cell E13. I again start with the $sign, type in E. It could be a lowercase or an uppercase 13 times. The column sum is in the cell C15. So type in C, then $15 divided by the grand total is sitting sitting in cell E15. Is that right? Yes. So this time type in $sign E, $sign again 15. Now keep in mind that your table may be in a different range in your Excel sheet. In my Excel sheet, the table is sitting in this range. So you may have different letters and numbers representing rows and columns. All right, I will click enter or hit enter. I got the same number as I got before. Now if you drag it down, the 1740 is going to be the expected count for the 1774 or the cell C14. Now let's double click on it. So as you see, Excel took the row sum for the second row, times it by the column sum for the first column, and divided by the grand total. What these $signs do, first of all, let's look at the denominator, the $sign E, $sign 15. If you type in those $signs, that tells Excel to hold the cell constant. So when you move down, Excel will not change the position of the cell to the second cell. As you move down, that does not move down. And for the numerator, this $sign E, it's telling Excel to hold the column constant. Don't move the column, but move the row. So as you move down from the cell E13 to E14, the only thing that will change is the row, not the column. The second factor here, C $sign 15, is telling Excel to move the column, but don't move the row. Okay? So just apply this whole thing. You could just drag the plus sign of the 4 squares. Okay, so I could drag it to the right and then drag down. You get all your counts. So let's one more time. Let me make the labels. This is yes, no, yes, no. All right, so assuming that independence holds true, if, meaning that if the two variables were independent, the expected count, or the count under independence here would be 1200, or 1202. For the second one, the expected count is 1740. The observed count is 1774. If the two variables were independent, the value, the expected count or frequency would be 208, but what we observed is 242. Okay, so next step is to get the test statistic. This is a chi-square test. You can use your formula to obtain that chi-square value, or you can just ask Excel to immediately find the p-value for you without doing any intermediate steps. Let's go over here and say p-value. We'll do that in this cell J15. The syntax for the chi-square of for the p-value of this chi-square test is, let me zoom in. Type in equal. The syntax is chi-test. As simple as that. It's CHI test, open parenthesis. Now, there are two arguments that go into the function of the chi-test. The chi-test is asking you for the actual range and expected range. The actual range is the same as the original data or your observation. To input that actual range, go back to the original table and select the 4 squares with the mouse right there. Okay, I'm actually going to type in where the cells are. In your Excel, if you just select the 4 cells, it will type in the address automatically for you. My cells are sitting in C13 through D14, comma. Next, you're asked to input the expected range. The expected range corresponds to the cells that have your expected values in them. Just select the 4 cells. As you see, Excel automatically inputted the range that contains those values. Close parentheses, hit enter. There is your p-value for your chi-square test, or the test of independence. Well, what's the conclusion here? We assumed independence. That is the original assumption. So yeah, call that HO. We made that assumption, and under that assumption, we got a p-value of almost 0.1%, meaning that what we have observed here under the assumption being valid is highly unusual. Therefore, you're going to reject HO that assumes independence holds true. So again, you can see a consistency between the results that I have obtained for this test and the results that we have obtained using previous methods.